So we did this yesterday. We laid this out. We did your frequency yesterday by your tally marks. We added a midpoint, and we're going to show you why we used a midpoint in a little bit because that's what's going to go on your graph. We did a relative frequency. This is just part over whole. It just gives me a ratio. Your cumulative frequency says accumulate your frequency. Start with your smallest one. Add the next one. 7. Add the next one. Add the next one. And the next one. One more. One more. This has to be equal to this. Now, way back in the day when you guys did cumulative frequency graphs, we always had a little problem with it. Because when you made your brackets, you did a bar, then a bigger bar, then a bigger bar. Technically, this bar includes everything before it. So they all include everything before it. So we start with your smallest one, 2, and we go in and add 5, then add 12, then add 18. It should equal what your total frequency equals. Now, class boundaries are a little tricky. We have a little bit of a problem because if you did this, here's my number line. 33, 34, 35. I put this on a piece of graph paper, right? And you did the first one, 26 to 34. Here was your bar. Then you came over here and you did 35 to 43. There's your bar. You got a gap. Yet you guys never put a gap in between your graphs. You were told that your bars should touch. But technically, what happened to that little gap between there? So in statistics, what we do to technically make this right, we just say, okay, expand this guy halfway. Expand this guy halfway. Now my bar actually goes like this. There goes my bar. So I kind of like just make them meet at the halfway. Will I ever find a 34 and a half in this, have a half of a person that says yes or gives me an age? No. So I'll never get, it's not the age that's the 34, it's the people that I'm counting their ages. So I'll never get a half a person. So our rule of thumb for class boundaries is drop the lower limit, negative 0.5, and add to the upper limit, positive 0.5. It's kind of like, I always tell my classes, if you put an air conditioner unit in your window, you have those little accordion things that pull out to me. All we're doing is pulling these things out to me. Does it give me any more air conditioning in those little accordions? Nope, it just takes up the slack to the edge of the window. So I drop this 25.5 and I raise that 34.5. I drop this 34.5, I raise this 43.5. Do you see from here to here? From here to here? There's no gap anymore. I end at 1, I start right there. Right here is where I started, 34.5. There's no gap anymore between my bars. Because technically you guys really had a gap. But we told you, don't put any spaces between your bars, make all your bars touch. But technically you had a gap. So we get rid of all the things that shouldn't happen. And all you got to keep doing is dropping the lower end by 0.5, adding 0.5 to the upper end. It doesn't change your tallies anywhere because I'll never get a half a person count. And I just won't find that. So it doesn't affect your tallies. All of it is the aesthetics of your graph. You can see where one ends off, the other one begins. Okay? your charts should be complete from our data. All we really have for our data is just the 50 ages of the ages of the 50 most powerful women from 2012. That was our data. From that, we set up our classes. We found your class width. We set up our classes. We did our tally. We found our frequency. They have to add up to 50. We did our midpoints. Question, Olivia? Okay. We did our midpoints. We did our relative frequency. We did our cumulative frequency. And we did your class boundaries. Now, some graphs you can use a midpoint. Some you can use a class boundary, which it'll make sense when we do them. But we needed to complete our whole table before we could graph. So if you kindly turn the page to '44. Everybody have this? Because I'm going to have to erase this. I don't think I have their pages. They're broken here. Yeah, I see. Perfect. This is a frequency histogram. Let's just talk about this for a minute. This was the data that we did in example 1. This was the navigating systems, the GPS systems, the prices. Now, we tallied them up. I know they're hard to see, but they're also in your book. So they're a little bit harder to see, but they are there. Now here's where I want you to see. Here's their x-axis. This is a midpoint. The one on the left of the page uses a midpoint. See how nice and clean that is? There's no like such and such to such and such. It's a midpoint. Your line flows a lot better with a midpoint. I use the midpoint for frequency histograms because when we do a relative frequency histogram, we need the midpoints of these bars. So I use the midpoints. If you look to the right, they use an upper class boundary. So do you see it in the bottom? It's kind of hard to see up here, but it's on yours. This is your upper class boundary. So they said the first boundary went from 64.5 to 104.5. Then they took just the edges of all the bars. And that's where they marked it off. They used an upper class boundary. The first one you have to go down and use a lower class because you have to have a starting point. This is nice, but it doesn't help us for relative frequency. So for frequency histograms, we're going to use the midpoint. And the reason I say midpoint is because if you look at page 45, I need you to look at your book. You see that little line graph there? See the little line graph on page 45? That's called a relative frequency polygon. No, that's just called a frequency polygon. Sorry. This is just called a frequency polygon. Here's the difference, and here's how we make that. You guys never did this one. This is a new one for you. We make that by taking the bars, keeping the same y-axis, the same x-axis. We need the midpoints, so that's why I like to use the midpoints. And all we do is we take the midpoints, pretend this is the midpoint. I'm a little off. We take the midpoints of all of these bars and we connect them. Now, doesn't that kind of look like the same shape as our bars? But the problem is this. I have no beginning, I have no end. So for the relative, for the frequency polygon, what we have to do is drop this guy down one more midpoint. Just take the midpoint that would be before it. Just subtract 9 from your first midpoint. And add 9 to your last midpoint, whatever your class width is, and ours was 9. Because we need a beginning and an end. Now, sometimes what this does is it pushes it out of the 0. So we're just going to make a little break in your graph. See the break in their graph? We're going to use that little break, and we're going to put our midpoint there. It's just so that it has a beginning and it has an end. Otherwise, the graph is kind of just sitting on the page somewhere. which our graphs usually have a beginning and they have an end. We're going to do all those together. So you'll get to see this a little bit better. But I want to show you that the frequency polygon has the same look as the frequency histogram. Now the reason they do this is in the business world, they don't always like to look at bars. They like to look at the bars when they're comparing them. There's usually like double bars. They like to see the bars. But the line segments kind of shows a little bit more of your rate of change, your steepness in here. So they like to see the steepness of a line. Where's it going? My sales up and down. My prices up and down. Why are these prices so high? Why are these so low? You know, why are these buying my lower prices and these people are not buying my higher prices? It tells me that right by looking at this. This was the prices of your GPS systems. So more people are buying your lower price than buying your higher price. Yet I had 2 people out here that bought my most expensive GPS. Okay? So looking at the lines are sometimes a little easier than looking at a bar. You can kind of see the rate of change a little bit. If you use the upper class boundary, you have to change your x-axis again for midpoint. Frequency polygon uses a midpoint. I put that in your note page as well to where your x and your y-axis is. So therefore, when we do a frequency histogram, I always use the midpoint because this guy also uses a midpoint. Notice each one of these has a title and a label on their axes. It's as simple as GPS, my X represented my prices in dollars. Ours represents our ages, okay? And frequency, you can just give me frequency F. If you're doing a cumulative frequency, just say cumulative frequency. That's what I'm concerned about for that part. But your graphs need a title and all the labels. And all your graphs have to be done pretty precisely. I don't want to see like, and I'm going to give you graph paper, but sometimes we do them and we kind of wing them. But don't give me like, and squeeze something in, like right in here because you forgot to add one, and squeeze one in here, or squeeze one in here because you did a mistake. Redo it, because they all have to be evenly spaced apart, or your graph is going to be very misleading. The nice part about this, look where your graph starts. It starts right here at the edge, doesn't it? So if this is a little off and they start at 64, they put a break in there because it didn't start at 0. Your 2 axes have to meet at 0 if this guy is a frequency. So if this one is a little off, just put a little break like that and then start it. But notice you don't have that big gap because we didn't make up our own intervals. We used your data to start your intervals. We put your first piece of data out there. That was the beginning of that interval. So you're not going to have any blank spaces on this, which is kind of nice. And these guys won't be sitting, your frequency polygons won't be sitting up somewhere without touching the bottom, because we'll have everything spaced apart. Questions on this part? We're going to go ahead and we're going to make these graphs, or at least a couple of these today. They did theirs. This is in theirs. This is ours, but we already filled out our whole thing. This is what your frequency graph is going to look like. So we're going to build this in a minute. We're going to build this together, and then we're going to do a polygon. And we're going to build these together. I don't have graph paper on mine, so I'm going to have to kind of wing mine. But you're going to use graph paper. So you're going to come down here, make a line. You're going to go like this on your paper. You're going to make a line down here, and probably like 3 boxes up across here, so that you have enough space to write on the bottom. I'm a little at a disadvantage because my table I can't keep in front of me. I don't have a copy of it, so well, you'll have to help me out. Now, title. We're doing your ages of the most powerful 50 women in the world as of 2012. So we're going to call this the ages of the 50 most powerful women in 2012. Needs a title. The x-axis, these are your classes, and they are the ages of the women. The y-axis is your frequency. So we're just going to write frequency. Now your frequency goes from, what is your highest frequency on your table? 18. So I need this to go to, let's say, 20. Count before you write it. If you have 20 boxes, go by ones. If you don't have 20 boxes, maybe every 3, put a 5. 5, 10, 15, 20, whatever works for your size graph. So before you start writing it, count them. See if you have 20 boxes. Do you guys have 20 boxes? You have 18 boxes to go up? You can actually go up to 18 because that's our highest one, right? So you can go by ones. If you don't, go every 3 and make it a 5. But the key is, this has to be incremented evenly. Now, if I go by every 5, I have a lot of extra space. So maybe I want to go by 4s or 3s. Or if you go every other, well then you'd be 2 should be the same as 1. Try to space this as far as possible so that you use your whole graph. So maybe I want to go by 4s, if this works better for me. And I get up a little bit higher into my graph. Let's just make your graph look as good as nice as possible. What happens when you don't use your space, your graph is very squished. So if my graph is just squished in this little area, it looks like I hardly have any people, doesn't it? If I spread it out, it looks like I have a whole lot of people in those ages. So your graph is what is important. And count before you write them in. Now your classes, what did your first class, was the first midpoint? 30. So it's not starting me at 0, so I have to put a little break in here. Put your midpoints. Give a little space here and equally space apart. We have 7 classes. Count how many boxes you have across the bottom. You have to write 7 of these things. And actually, if we bring it down, well, this one is fine. You have to write 7 of these things. So if you have 25 boxes, maybe go every 3. It'll give you 21 spaces. So make sure they're equally spaced apart. These are my midpoints. This is almost the same as what you guys did for your frequency histograms, but we just use your midpoints. It cleans it up a little bit. We don't put your intervals down there anymore. We could use an upper class boundary, but we're going to use your midpoints for this one. So what was your frequency for your first class? 2. 2. Make a bar, make an equal space bar that goes up to 2. I'm sorry, my board is really off. So try to make it like halfway at the 2. I should reset my board. I need to reset the board. But every time I reset it, it still goes off on the edges anyway. What's the next interval? Look at your chart. What's the next interval? 5. Now, continue here and go to 5. Well, it depends what you did. My 2 is halfway between 0 and 4. I did by 4s. My 5 is 1 more than 4. Whatever your y-axis has to be. Shouldn't that be a midpoint? That's a midpoint. That should be halfway between your bar. That's your midpoint. Well, yeah, because my board is a little bit off, so kind of deal with my board. But you have graph paper in front of you, right? So make it equal around there. Make it equal. That's your midpoint. What's your next one? After 5. 12. So we're going to come up here as close to, I have a 12, as close to 12 as we can get, and bring it down. Yes, I do. At the end for 10. Okay, okay. Olivia at the Superior Health Office. Next one. What's the next one? 18? Yeah. Thank you. So I'm going to come up as close as I can to here. And mine is by 4, so I'm between 16 and 18. Next one. What's after 18? 11. So I come back down to 11. I'm a little short of the 12. Then we're going to have a 1 and a 1. A 1 and a 1. So try to make a little 1. And the next one the same size as that.
Should I have spaced it out by 9 like you did?
However, you want to make it fit your graph paper. Why?
Because I spaced it out by 15 and then I didn't account for the 9.
Well, you don't have to account for that, but these have to be equally spaced apart. So now your bar is fine. You have a break here. So your bar is 1, this, 3, 3, 3, 3. 2, 2 and a half. Oh, 2 and a half, 2 and a half. Oh,
Yeah, but it's not. You get 30 seconds. Wow.
That you have to have the midpoint.
It's not even.
So this bar, this
Yeah,
guy
it's
has to
even
be
getting this right. There we go. And going 1 to the left and 2 to the right.
So I'll grab another piece of paper, and are these equally spaced
It's as
here?
halfway as it was getting, right? At least at this rate.
See, it's not as easy as it looks, right?
Not at all.
Not at all. I should be able to count the boxes on this side and this side to make sure that they're equal. I'm sorry about my board, but as close as you can, these have to be equal. Your bars have to be the same width apart. Everything has to be equally spaced, or what you're doing is throwing off your graph. When someone looks at your graph, that picture is worth 1,000 words. So when they look at that, and I've got a graph of this, I do have a graph of this up here. We looked at it before. Put the graph, that's your relative. Here it is over here. Look at how nice this looks. They did by 3s, that was fine. Aren't these equally spaced apart? Aren't these equally spaced apart? My midpoint is in the middle of my bar. My bars are crisp. I can kind of see what's going on here. I can see where most of my ages are falling. There's very few young ones, very few older ones. Absolutely.
I thought the other graphs.